As I told you earlier, I would like to use Helm to install everything on my cluster instead of kubectl applying a bunch of YAML. So in this section, I'm going to give you a quick intro to Helm so that we feel comfortable using it in the following parts of the workshop. So Helm is a kind of package manager for Kubernetes. Some folks would even say it's the missing packager for Kubernetes, something like that. So we can use it to find existing packages and install them. These packages are named charts. So we can find packages the same way, you know, that you can find packages with apt or yum or brew if you're on a Mac. We can install them, we can configure them, and we can also use it to package our own stuff, whether it's because we want to publish that to the world or because we want to use it internally. It's great for both use cases. And Helm is also a CNCF graduate project. So what does that mean? Like, does it mean that now it can go to college or something like that? I will tell you a few words about this graduation status in a few minutes. So why do we need something like Helm in the first place? When we start working with Kubernetes, often the first few commands that we use are things like kubectl run, kubectl create deployment, kubectl expose. It's great to get started, but very quickly we turn that into YAML so that we can manage our applications in a declarative way. We have this YAML manifest, we can put them in Git repos, and that's a way to know what we want to have on our cluster. And when we want to make changes, instead of doing like kubectl scale this and kubectl label that, no, instead we edit the YAML and we apply that YAML. That YAML is safely committed to a repo, so we have, you know, a log of all the operations that we want to make. We can rollback easily, etc., etc. But very often we need to customize that YAML. We need to adapt it, and you know, very quickly we end up for our application with, for instance, like 3 YAML files. You know, you have, okay, this is the YAML for production, this is the one for staging, this is the one for dev, and we have different scaling parameters, maybe different domain names, maybe even some entire components that are not running in dev, etc., etc. And of course, there's going to be a README or something like that telling to the user, okay, before you deploy this in your environment, you should change this YAML here and there to adapt it to your needs. And that's what we will see when we want to install, for instance, external DNS or the metrics server, like things like that. They give you some YAML and they're like, okay, put your API token or your server address or whatever in there in the middle of that YAML. So that's where we have some extra tooling to kind of automate that, to do that in a more reliable way. You know, we could do some, if you're a shell expert, you can do a little bit of sed or awk or use things like env-subst to kind of patch your YAML on the fly. But very quickly, it becomes better if we have some tools like Helm, but also customized, for instance, on some languages like Q that can generate or transform YAML. The idea with Helm is that we can do something like this. I can do Helm install application and I can set parameters, I can set some values, and Helm is going to patch, so to speak, my YAML to fit my configuration. Okay, so a little bit of terminology, vocabulary, etc. The Helm packages, as I said earlier, are called charts. These charts can stay like internal or be published on repositories, and when we publish them, it's also a good idea to index them on the artifact hub. The artifact hub, it's not exactly like the Docker hub. You know, on the Docker hub, we actually have a bunch of Docker images, so that's a huge collection of Docker images. The artifact hub is more like an index, a little bit, you know, like the Yahoo directory back in the days. It's just a big index with not only Helm charts, but other things as well, like operators, policies, etc. And that's a good, you know, central place when you want to look for other charts as well. You can go to that artifact hub and look for what you need. I want a replicated Postgres operator or something like that. You can find that on the artifact hub. Helm will also manage the life cycle of our installed applications. So what does that mean exactly? It means that when we install something, Helm will keep track of that. And when we want to uninstall it, for instance, it's going to remove these resources. When we upgrade, it's going to keep track of the successive versions so that we can do a rollback later if we need to. And last but not least, even if Helm is maybe not the package manager, I would argue that it's a very good package manager and probably the most important, the most popular one in the world of Kubernetes. I told you earlier about that graduation status for Helm. What does that exactly mean? So within the Cloud Native Computing Foundation, we have a number of projects. I think now we have hundreds of them, but they have different levels of maturity to indicate kind of how stable it is, how much of stable governance there is, things like that. The first graduate project in the CNCF was Kubernetes itself. And last year, when Helm graduated, it was the 10th project to do so. To give you an idea of what kind of projects are graduate projects in the CNCF, we also have Prometheus, Containerd, and a few others. So what does that mean for us? It means that the project is stable, that it has a good and open governance. It's not under the control, of one company or something like that. No, there is community behind it. It's pretty open, etc. So it's a good sign, if you're thinking, oh, should I get that project or that other one? When a project is a graduate project, it's a really positive thing. That being said, how do we work with Helm? So Helm itself is a CLI tool, and we are going to use it to find charts and install them. So what exactly is a chart? A chart it's basically a tarball, an archive, with a bunch of YAML files, like Kubernetes manifests, but they are not exactly YAML files, they are YAML files with templates in them. Templates as in, double curly braces and expressions like this, that dot image, dot version, something like that. Well, it's going to be more something like dot values, dot image, dot version, but we're going to get there in time. And so, for instance, in the YAML for a deployment, we would have something at some point like image, colon, and then this. And when we install that chart, Helm is going to evaluate that template and evaluate all the blocks in these double curly braces to replace them with what we need. And we don't just have placeholders, but we can also have conditionals, we can have the dynamic evaluation, etc., etc. So these charts are then placed on repositories, and repositories is, again, a collection of tarballs. And these repositories technically are just HTTP servers. So that means that if you want to publish a bunch of charts, all you have to do is create a bunch of tarballs, put them on a web server, and job's done. So pretty simple. We don't bring in new protocols or new servers or whatever. We're using good old stuff. Now, there are some little differences between charts and packages, to clarify things. When we install a package on most systems, the package contains the binaries, the libraries, the programs, etc. So a package could be fairly big. If you install the package for Firefox these days, it's probably, between 50 and 100 megabytes, while a chart doesn't directly contain images and binaries. A chart only contains YAML templates, a little bit of metadata, so it's going to be fairly small, but it will contain references to images, and these images could be fairly big. So the flip side of that coin means that a chart is not self-contained. If you just have the chart, that little maybe 20, 50 kilobytes tarball, it's not enough to run your thing on Kubernetes. You will also need the images that go along with that chart. Another big difference between charts and packages is that on most distros, when you install a package, you can only install it like one at a time. You know, like if I install, let's say, Bash on my system, I can have Bash version 3 or version 4, but not really both at the same time. In fact, when I install a new version, it's going to replace the old version. That's the whole point of a package manager. While with Helm, you can actually install the same chart multiple times side by side. So for instance, if you want, you can have like 5 different copies of MySQL or Postgres or Mongo. They could be the same version, they could be different versions, that's completely up to you. So that's another difference right there. Of course, I know that on some distros, actually most distros, you can have stuff like Python 2 and Python 3 side by side, but technically if we look at how that works, this is because instead of having a single Python package, we have a package Python 2, we have a package Python 3, and that's what lets you have them both side by side. But generally speaking, when you install a package, you just have one version of that package. Now, I'm going to briefly mention a few things about Helm 2. You should know that Helm 3 is what we use today, like every new install, every new deployment, that's going to be Helm 3, but there are still a lot of tutorials, documentation out there about Helm 2, so I'm going to say a few words about Helm 2, but really there should be no question here. We should be using Helm 3 today. So how do we install Helm? Well, Helm is a Go program, so it's just a single binary. You can get that binary or you can use that little script here to install it. I think I already do have Helm on my machine, of course. Awesome. So we're good here. If you're still using Helm 2, you should totally upgrade to Helm 3, but with Helm 2 there is a business with a component called Tiller, and that's one of the reasons why we're moving to Helm 3, because that thing was kind of confusing, especially everything related to permission management around it. So if you're still using Helm 2, then you have to use Helm init before you can start. But again, if you're using Helm 2, please upgrade to Helm 3. All right, so with Helm, we work with these repos, and before we install charts from a repo, usually we're going to add that repo. So for instance, when you see a Helm command, like, you know, when we do Helm install my wonderful app, and then we're going to indicate a repo name, like some repo slash the name of the chart, like the app. So when we see that, this is going to be the name of the release. So I'm going to create a release called My Wonderful App. And this means go and get that from some repo. And in that repo, this is the chart we want to install. Now, how does Helm know where exactly is some repo? Like, is there a central index or something? No, it knows because we do Helm repo add some repo, and then we indicate the URL for that repo. And very often it's going to be something like blah dot or like charts.blah.io, something like that. And so each time somebody tells you, hey, install my Helm chart, they will give you the name of the Helm chart and the address of the repo. And just to give you a little idea, this is the repos that I have on my machine at the moment. So you can see that when you work for a while with Helm, you end up with what, maybe 15-ish repos here. There is GitLab that we're going to use in a moment. There is traffic. There is my friends from Enix. There is Bitnami. Bitnami is a name that you will see a lot around Helm because these folks are authoring and maintaining a huge amount of really top quality charts, etc., etc. All right. So now, how do we find charts? I was saying earlier, with Helm we can find and install charts. Well, how do we find them? So we can go through the Artifact Hub, or we can use the CLI. So here I'm going to install something called the OWASP Juice Shop. It's just a little demo app and it's used for security challenges. So if you want to learn, like how to hack into web stuff, you can install that, and then there are a bunch of tutorials teaching you like how to find and exploit web vulnerabilities. Pretty interesting if you are security oriented. So how can I find that? Well, my first option would be to do like a Helm search. And when we do Helm search, we can say search in the hub or search in the repos that I already have added here. So let's search on the hub and OWASP Juice, for instance. And that gives me a few results. And now that that command line search is not so great because you can see that the links here are truncated. So how do we deal with that? Well, one option would be to do a -o JSON, and then there's going to be the URL somewhere in there. Another option would be to just go to the artifact hub and search here, OWASP Juice and Juice Shop. That's the one here. So we click there. And so you have a little bit of, description, what is this? And here, this is telling us how we install it. So it's telling us, okay, you do Helm repo add. Okay, let's do that. So I already had that repo, so we're good. Then the second step, let's see this. So what does that command look like here? Sorry, let me like this. So this says Helm install. We are going to call that release my juice shop, and we're getting it from that repo, and this is the name of the chart on the repo, and this is how you set a specific version. This is optional. If you don't put the -- version, it's just going to get the last one. So I do that, and there we go. That installed the application. Now you know how it is with Kubernetes. When it tells us installed or deployment created, it means that it's still working on it in the background. So if I take a look at what I have here, you can see that my juice shop, etc., is now in container creating state. It's not quite up yet, but if we give it a moment, the container will come up and be running, and after maybe a minute it will be ready and accept connections. Right, and we even have a service for it right there. Awesome. So we installed that chart, so that's great. Now we can view what has been installed as well with Helm list. So that's going to tell me, yep, we have one release right there. And now what we can do is that we can also list all the resources that have been installed by that specific release with that command here, with that selector. So what is that selector here? A little reminder about selectors in Kubernetes. The selector is a way to say all the resources that have this specific set of labels. And as it happens, this particular Helm chart did label all resources in a special way. Let's look, for instance, at the service, kubectl describe service my juice shop. When I have a look at that, I see that I have a number of labels here, and I can use these to find the components of my application. For instance, okay, app kubernetes io/instance my juice shop. That looks like a very good candidate for a selector. So now I can do kubectl get all -- selector, and I put that selector there, and that's going to list. You can see we have the deployment replica set pod and the service. And it's been a couple of minutes now, so this pod is up and running, so we should now be able to connect to that application. Great. Now, if I want to connect to this application, I have like one minor problem. By default, it created a cluster IP service, so I can't connect to it from outside. We could use the kubectl port forward or kubectl proxy commands that we saw earlier, but I would like to expose that application to the world. So how do I do that? Well, I could do a kubectl edit on my service or kubectl patch like we also saw earlier, but I could also configure my chart. I could tell Helm, hey, I want that service to be a node port, for instance, or a load balancer service. How do we do that? Well, with Helm, we can pass a number of values to a chart. The values are a number of parameters that are going to be injected in the templates evaluated by Helm. So each chart is going to have its own values. So, you know, we have to look, okay, what are the values, the parameters, the tunable things exposed by this chart, but they often follow some conventions. So how do we find out? Well, there are a couple of things we can do. First, we could go back to the artifact hub here and we get some interesting documentation here. So that's the first step. But if, like me, you like to stay within the comfort zone of your CLI, you can also do Helm show, and then you can do Helm show readme on, that was secure code box juice shop, yeah. So this is going to show us the readme. Well, you know, that's exactly the same readme that we're seeing here. And to be honest, it's a little bit nicer to look at that on the web page because at least the markdown will be formatted properly, but you know, why not? And we can also do Helm show values, which means show me all the values that are set in the chart at the moment. And so, as you can see, this is a YAML file. And if we scroll a little bit in there, there we go. There is something interesting right there. We have service type cluster IP. And so I would like to change that. I would like the service type to be a node port instead. So how do I do that? I'm going to set a value. I'm going to say that service.type should be node port. Okay, so I have a couple of options here. I could install another copy of the app, like my public shop, and I would add here -- set service.type equal node port. That's one option. And actually, let's do that with a load balancer service, for instance. All right. And that's it. Now I have another copy of the app. If I do my Helm list, I have my juice shop and my public shop. Now, what if I want to update that existing deployment here and I want to change it to be a node port? Then I can do a Helm upgrade. And when I do my Helm upgrade, I have to give the name of the release, so my juice shop. Then I have to indicate the path to the chart again, so secure box juice shop. And here I can put my -- set service.type node port. There we go. And now we can see that we are at revision 2. If I do Helm list, this is showing revision 2 right there. And if I do kubectl get services, we can see that, fair enough, my juice shop is now a node port. And since that's a node port, we can see the port number here. It means that I can connect to any of the nodes of my cluster on that port number, and I should see the juice shop application. All right, let's find out the IP addresses of our nodes. Okay, let's get the first one here. Let's add the port number behind it, like this. Now let's put that in our browser, and that gives us the Juice Shop app. So as I was telling you earlier, this is a demo app that has a number of security vulnerabilities, and it's used to learn about how to secure web applications. Right. So we've set some values here, we did connect to the app, awesome. So that was a very basic crash course into Helm, and we are going to use it in the next sections to install the other components that we need on our cluster.